Water-friendly farming is a landscape-scale project covering 3 headwater catchments. It's been running for more than 10 years now, and we're exploring methods of reducing flood risk downstream, different approaches including leaky timber dams, tree hinging and floodwater storage areas, all relatively natural approaches to reducing flood risk downstream.
By natural flood management, we mean working with nature and natural processes to help store and slow water in the catchment before it reaches downstream sensitive receptors. So, helping river catchments to store more water and slow it down on the land before it gets into watercourses, slowing down the flow of the water once it's in the watercourse, and then also potentially pushing that water back out of the watercourse and onto the floodplain. Water-friendly farming is a long-term project, and it's been investigating the effectiveness of a range of natural flood management techniques using both modelling and real-world testing across a range of storm events.
We installed the first leaky dams about 10 years ago. The first ones we installed were made of cordwood, short lengths of timber sourced from local woods. But what we found was that many of those were destroyed on larger watercourses. On the mainstream, where the small dams are being destroyed, we have had to move to much larger, better designed structures with longer lengths of timber, whole tree trunks, larch brought in from elsewhere and keyed into the bank, 2 metres into the bank side, to make them as strong as we possibly can, and leaving a large gap at the base of the dam to allow water to flow through for most of the year. So we only want to hold water back during a peak flow. So because even the large dams that we've created have been badly damaged during storm events on the main stream, we're exploring another option, which is tree hinging. So this is part felling trees into the channel, a bit like hedge laying but on a larger scale. So we have a living dam across the stream that will capture debris during storm events and hold water back, so that we're reducing peak flow, reducing flood risk downstream using a more natural structure.
So we can predict how much water storage we need to find in a catchment to have a beneficial impact downstream, and we know what sort of contribution the leaky dams can have to that water storage target. So the challenge is to find the space for that extra storage in the context of a typical lowland agricultural setting, and then to test those predictions with actual data. So here we're creating extra storage capacity by excavating scrapes in the floodplain. Now these are designed to store and attenuate flood water during a storm event, but importantly, once that storm has passed, they drain down quickly so that we regain that storage capacity in the event of another storm coming along. We all see that the frequency and severity of flooding is increasing, and that's only set to continue with climate change. It's becoming more and more apparent that we can't just rely on building our way out of the problem, and there's a growing interest in looking at the potential benefits of natural flood management to complement those more engineered, traditional forms of flood defence.